Today let us learn about division involving decimals. You have been dividing numbers all your life. So what is new? Let us find out. Suppose you have to divide 115 rupees among 4 people. So how will you do that? Now, what is the problem with this division? It looks fine, right? But the problem is with this non-zero remainder here. What do I do with this remaining 3 rupees? You might think 3 is not a big deal, but think about a scenario where it is a government or a company which has to give away billions of rupees in salary to its millions of employees. Then the remainder here will also be bigger. Now, using decimals, we can reduce this remainder to 0. How do we do that? And think, why have we stopped at this point? Why have we stopped the division at this point? Because there are no more digits left in the dividend. That is why we had to stop here. Now, by making this number here, the quotient here, into a decimal number, or in other words, if you put a decimal point here, this allows you to add a 0 to the dividend, which comes here. Now this has become 30. You can continue the division, and now remember, this adding this 0 here is not just at this level, at every level. At every level, as long as you are getting non-zero reminders, till you get 0 as a reminder, you can keep on adding 1 0 at each level till you get 0. So let us start the division and see how it looks. So there, I have put the decimal point here that allows me to make this 30. There. Now, again I have a non-zero reminder, but because of this decimal point here, I can again add a 0. So there, mission accomplished. We have got a 0 as a reminder. Now, not just in this cases, there are many cases where decimals help us. Let me show you one more example where decimals will help you to divide whole numbers. Now, we all know what is 25 divided by 1. We know the answer is 25. But what about 1 divided by 25 or any other division where your divisor is greater than your dividend? Then what will you do? Here again decimals will help you. If you put a decimal point here, then it allows you to add 1 0 to the dividend, but then 1 0 exactly. See, at each point we can add only 1 0. But what if that 1 0 is not enough? See, we have 10. And the divisor here is 25. It is absolutely of no use. Now the rule is that you can add as many zeros here, but to balance it, add that many zeros to the quotient as well. So 1 0 here means 1 0 here. But then 100 is good news, right? Because 4 there. We have got 0 as the answer. That's good news. So these are two examples where you divide whole numbers. The dividend and the divisor are both whole numbers, but your answer is a decimal. But then that is not our topic. What is our topic? How do we divide if our divisor or our dividend are both decimals? So let us start. Now the division involving decimals falls into two types. The first type where your divisor is a whole number. The second type where your divisor is a decimal number. Now let us start with the first set of cases where your divisor is a whole number. There is a very simple shortcut to it. Let us see what it is. What is 35 divided by 7? The answer is 5. Now, in the dividend, count the number of digits in the decimal place. Your answer also need to have the same number of digits in the decimal place. 1, 2, 3. 1, 2, 3. There. This is your answer. One more example. What is 81 divided by 9? The answer is 9. After the decimal point 1 digit, So this is your answer. This is the shortcut method. Let us do the same set of problems but in the usual division method. By now you know the answer. Now think of this decimal point as a rock lying in your way. What will you do? Just move it out of the way. Put it in the quotient. Once you put the decimal point in the quotient, you have to follow one important rule. What is that? You can take only one digit at a time. If you want to take more digits, you have to balance it out by putting that number of zeros in the quotient. Now, you are allowed to take one digit, but it is 0. No use. So, you need one more digit. So, that means 1 0 in the quotient. That again not enough. You need one more digit. That means one more 0 in the quotient. Now, 35 is good news. There. Finished. The same thing, the second example. How does that work? There. Do not worry about the decimal point until you come to it. 8. Not enough. You need one more digit. But who is blocking you? There. After that, you are allowed one digit. So that is 81. Again, good news. There. Using just this simple rule, now let us do two bigger numbers. Now let us solve the first question. What did we say? Do not worry about the decimal point until you come to it. Don't worry about it. Till that point, do the usual way. 1. Now, before you go any further, who is blocking you here? The decimal point. Remove it out of the way by putting it here. But what is the rule that we learned? Once you put a decimal point here, you are allowed to take only one digit. You want more, balance it by adding that many zeros. However many digits you want. 1 digit, 1 0. 2 digits, 2 zeros. So as many extra digits you are taking from the dividend, add that many zeros there. So that is the answer. We go on to the next question. Here the divisor is 17. Again, it is a whole number. 17 tens are 170. So half of that would be 85, right? So that is 85, 3. This one comes here. 17 twos are 34. So there. But then, before you take the 2 here, who is blocking your way? The decimal point. Move it out of the way. Then you get here. Again, there's only 1. Take 1. Then that is 3, I think. 7 threes are 21. So 17 into 3 will also have the same last digit. There. Good news, right? In both the cases, we have successfully got 0 as a reminder. Now we go to the second set of conditions where your divisor will be a decimal number. Now we move on to the second set of questions where our divisor is a decimal. To understand the situation better, let us write this question in the form of a fraction where our dividend becomes the numerator and the divisor becomes the denominator. Now we know what to do when your divisor is a whole number. So let us make this into whole number. How do you make 5 into a whole number? We have already studied that. I will give the link below. All you have to do is multiply it with 10 because there is only one digit here. How do you make 0.008 into a whole number? Multiply it with 1000. 3 digits, so multiply it with 1000. Here, multiply it with 100. There are 2 digits in the decimal place. So, all you have to do is multiply the denominator with 10. But then, what is the rule for the equivalent fractions? Whatever you multiply the denominator with, you also have to multiply the numerator. There. This is your answer. 25 divided by 5 is 5. So this answer here is 50. The same way, continue here. What do you do? Multiply with 1000. But then there is only one digit here. It has to move by 3 digits. But only one digit. So for the remaining 2 more digits, just add 0. The answer here would be 400. Now for the last question, you have to multiply both the denominator and the numerator by 100. It moves 2 places here. So this becomes 30.6. And the denominator becomes this. Now what do? Now you just continue it in the usual method. What is the usual method? This is the divisor here, the dividend here, 15. When 15 divides 30, what do you get? So you put a decimal digit here and then this 6 comes down. So now what do? After you put the decimal point here, you are allowed only one digit and you have taken that digit here. If you want more digits, what do? Put that many number of zeros in the quotient. That allows you to put a 0 here. Okay. This is your answer. Now you have seen 2 different cases. One set of cases where your divisor is a whole number. Another set of cases where your divisor is a decimal. Why did we not consider the dividend? Why are we breaking our head only over the divisor? Let us discuss that. Now we learned about 2 cases. One where your divisor is a whole number and the other one where your divisor is a decimal, and we solved it in different ways. How did we solve the first one? All we did is just divide 5 by 5. The answer is 1. Then we counted the number of digits in the decimal place and we did this. Simple. But what did we do here? We first made this divisor into a whole number. We did this and we got the answer 10. Why 2 different methods? Why do we think that whatever happens to the dividend, the same thing will happen to the answer, but it does not do so with the divisor? What is the difference between the divisor and the dividend? Let me show you an example. It is a very simple thing. If you have a numerator and a denominator in a fraction and you have the quotient, then you will notice that whenever the numerator increases, the quotient also increases. Let me show you one example. We will keep the divisor constant and we will keep on increasing the numerator and we will see the quotient also increasing. First, 10 divided by 10, 1. 50 divided by 10, 5. 100 divided by 10, 10. So you see, numerator increasing, answer is also increasing. Now, what happens with the denominator? As the denominator increases, your quotient will go down. Let us see that also. Here we will keep the numerator as a constant. And see what happens to your answer. We will slowly increase the denominator and see what happens. 100, right? Let us slowly increase it to 50. What happens? Your quotient is going down. Let us increase it further. See? So your numerator is a good guy here. Numerator is very flexible. If you have to multiply, say, 0.32 by 8. All you have to do is divide 32 by 8 and put this. Finished. The numerator is very flexible. Whatever you do to the numerator, you can do to the answer also. If you remember the earlier one question we did, see what happens there. Now we will see how the changes in the dividend and the divisor change the answer in different ways. Let us see that. Suppose your dividend becomes this. I'm just changing the question. I'm just making it a bit more smaller. Then what will happen? The same change in the answer. You do not worry. Why? Because the numerator, the dividend, is extremely well behaved. It's not a troublemaker. All you have to do is this. No drama of dividing and multiplying and all of that. Simple. But then, what if the dividend is same, but your divisor becomes smaller by 2 digits? First, your dividend went back by 2 digits. Now your divisor is going back by 2 digits. Then what do? Multiply both denominator and numerator with 100. So now what happens here? See, here also 17, here also 17. You have got the same divisor. Then what is the change? Here the dividend has increased. It has gone forward by 2 digits. You see the difference here? Your dividend has gone forward by 2 digits. So the answer will also go forward by 2 digits. So this will be your new answer. So you see a main difference here. Whatever happens to the numerator, the same change happens to the answer. Here it is going back by 2 digits. So the answer also it is going back by 2 digits. But then what happens to the divisor affects it in the opposite way. It increases that many places. Now we come to the end of this class, but let us just briefly go back to the example that we started with. What did we say? Whenever we have a non-zero remainder, using the decimals we can reduce it to 0. But does that mean it works for every set of numbers? Any two numbers you take and you divide it, then finally you will get 0. Is that what we are saying? The answer is no. Sometimes we do not get 0 because the quotient goes into a loop. What do we mean by a loop? The same thing starts happening again and again. It starts to recur. Recurring means it happens again and again. When that happens, when your quotient recurs, you will see that you will never get 0. However much you divide, you will never get 0. Let us see one such example. So consider 1 divided by 9. What do? You put a decimal point. That allows you to add a 0. Then again you get 1, but you have a decimal point here. At every level it allows you to add a 0. 1 0 and 1 be 1 0. Again 1. Again the same thing happens. So if you see, it just goes on like this. So there are many such decimals you will see. See 141414 or 0.237237. And in such cases, you will see the same set coming again and again and again. And at every level of your division, you will get the same remainder. You will see that this is just going to just keep on continuing. Such decimals are known as recurring non-terminating decimals. What do you mean by non-terminating? It does not end. It goes on and on and on. Recurring means what? The same set of numbers happens again and again. But you don't have to worry about that now. For now, the questions you will be given, you will always be able to reduce your non-zero remainder. You will be able to reduce it to 0. I think it is better to know about it now. In families and all, I've seen grandmothers telling stories to children about the solar eclipse. Phenomenon is a very simple one, right? What happens? The moon comes in between the sun and the earth, and therefore we cannot see the sun. It gets blocked in some parts of the earth. That is why the solar eclipse happens. But often I've heard stories that there is a snake up there in the universe. It goes and swallows the sun. That is why we can't see the sun. People often think that children can't understand science. That is not how it works. I think when you explain it, it is always better to explain the truth. You might not always get 0 as a reminder because sometimes your quotient will go into a loop. It will start repeating itself. Then in those cases, you will not get 0. Otherwise, for sure, you will get 0 inshallah. So, till I meet you next time, you take care. Assalamu alaikum.